Question 11. So it tells me to take logs of both sides. So let's just start by doing that. So ln y equals ln x to the power of x. Bring the x in front. And that's as far as we can go just for a second. Right. Okay, now we need to think about, it talks about turning points. So that means differentiation. And this is implicit differentiation. And I'm going to speed through it, but if you need to look it up, implicit differentiation. Okay, it's when we're kind of differentiating y's and differentiating x's at the same time. If I just quickly whiz through this bit. So this part here, this has got the y in it. This bit's actually easier, although it's got x, ln x. So what this is going to be, so if I differentiate ln y, that's 1 over y, and that's going to be dy over dx. You might need to look up that bit, okay? So over here, so I need to, in other words, I need to differentiate this part just here. Well, that's actually a product rule. Okay, so if you say u is x and v is ln x, so that's actually going to give you x multiplied by 1 over x. So all I'm doing here is I'm doing product rule, ln x, and that multiplied by 1. So this is going to give me 1 over y dy dx equals 1 plus ln x. So multiply both sides by y, and then we've got dy over dx. So 1 plus ln x. There we go. Right, now what was the question? The question was to work out this turning point. So in other words, when is this equal to 0? So it's going to be equal to 0 either when this bit's 0. Well, that can't be 0 because this is y here, isn't it? It doesn't equal 0. So it's when this bit equals 0. So 1 plus ln x. So take away 1 from both sides. We got minus 1 equals ln x. And if we e both sides, got e minus 1 equals x. If you want that as a decimal, pop it your calculator. 3, 6, 7, 8, 7, 9. There we are. Okay, so part B. So we need to show that this point here lies between 1.5 and 1.6. So all you need to do here is just to shove in 1.5 into this here, right? So I'm just doing 1.5 to the power of 1.5. Get an answer. And that's 1.8 something. And then do the same for 1.6. And that turns out to be 2.1 something. So there we go. Equals 2 is in between those two. Looks like it's going to be slightly closer to the 1.6 than 1.5. Okay. Right. And now we've got to use, so part C is talking about using the iteration formula that it's given me. And then I've just got to pop in 1.5 into here. So x1 equals 1.5, x2. So all you're doing here is just popping it into here. So the next one is 2 times the previous one. Okay, the previous term. And then to the power of 1 minus the previous term. And that one there, so that's going to give you 1.63299. If you work out, we need to work out x to the 4. So if you just repeat it, and if you set it up on your calculator, life will be a little bit easier for you. There we go. So if you just do the next couple, and then 1.673, make sure you do how many decimal places it actually says. Now, the easiest thing to do, to be honest on this bit, is just to set it up on your calculator, and you'll see what it looks like. Now, if you're not sure about setting this up on your calculator, what you've got to do is if you just put in your first value, 1.5, just press equals, okay? Now that value is now like our answer. Now if I just follow this through, if I go 2 times and then the answer, and that's going to be to the power of 1 minus the answer. And the beauty of this is that you can just repeat it. Here you go, look, I get that. That was that first value you just set, so that was x2. If I press it again, okay, that was this one. Press it again. Oh, look, okay. Now, the idea about this, describe the long-term behavior of this. Well, once you've set it up in here, just press equals a few times. Hey, wait a minute, it kind of sort of seems to be drifting between 1 and 2, doesn't it? It's getting closer to, oh, it's getting closer to 2, it's getting closer to 1. There you go, it seems to be settling down. Basically, it then settles on 2 and 1, doesn't it? So the correct terminology, you could just say it fluctuates between 1 and 2, or oscillates between 1 and 2. There you are.